Hello everyone, hope you're all doing fine. Welcome back. This is the second lecture of lecture series on equivalent resistance. In this lecture, we are going to learn about method of successive reduction in order to find the equivalent resistance. Okay, so yes, my name is Vijay Krishna and you're watching UpPhys channel. Let's get started. First, I request all of you to read out these three steps. Okay, don't mind about the English statements. I'm going to simplify. We are going to practice many number of problems. You will be able to remember it. Reading and by hearting the statements will not help you to remember it. Okay, so when we practice more and more number of problems, we will be able to remember it for longer period of time. Okay, we will solve three, four, five number of maybe five number of questions in order to make you understand how to solve, how to use this method to find the equivalent resistance. Okay, I hope you have all read the statements, right? Right? Okay. Now let me simplify this, for you. What we do first is we will identify the series or parallel combinations, simple series and parallel combinations of resistors in the entire circuit. Okay, and simplify those components one after the other until we get one single resistor. Okay, this is the simplest way to get over with it. Okay, let's look at the example here. We have 2, 3, 4 ohms which are connected in series to a 20 volt battery, and here it is also mentioned as 1 ohm resistor, 1 ohm internal resistance. Okay, so for this internal resistance, what I'm going to do is I'm going to mm, I'm going to okay I'm going to mention the resistance here, which is 1 ohm, now this 2 ohms, 3 ohms, 4 ohms and 1 ohm, all the four resistors are connected in series. As we have already learned, the equivalent resistance of resistors when they are connected in series are something like R1 plus R2 plus R3 and so on. All the resistances of all the resistors must be added directly. So here we have 2 ohms, 3 ohms, 4 ohms and 1 ohm. So R equivalent must be 2 plus 3 plus 4 and 1. 4 plus 5, 9 plus 1, 10 ohms. 10 ohms is the equivalent resistance of the given circuit. Sometimes the question may go little up, something like you may be asked to find the current in the circuit. Let us find the current as well. It is simple. We use simple formula of Ohm's law to find the current. As we already know, current is equal to V by R. As we have R equivalent here, I'm going to find the total current in the circuit. So I is equal to V by R equivalent. What is V? 20 volts by R equivalent is 10 ohms, 20 volts and 10 ohms. It will be 2 amperes. 2 amperes. 2 amperes is the current flowing through the circuit. As I've already told you, in case of series combination, the current through all the resistors, all the electric components which are connected in series will be same. That means current here, current here also 2 amps, 2 amps, 2 amps. I hope you may be able to see it. 2 amperes is the current through all the resistors. The question can even go upwards, something like you may be asked to find the potential here V1, V2, V3 and V4 as well. Okay, let's find the potential difference across 2 ohms. V is equal to IR. Again, I'm using the Ohm's law only. V is equal to IR. What is the amount of current that is flowing through this resistor, which is 2 amperes. 2 amperes into resistance is 2 ohms, which is equal to 4 volts. And if I want to find the potential across 3 ohms, okay, in that case current is again same and it is 3 ohms, which will be equal to 6 volts. You can even find 4 ohm resistor potential difference across 4 ohm resistor and 1 ohm resistor. and the potentials of all potential difference across all the resistors must be equal to the total potential which is supplied. Okay, let's say here the potential is 4, here it is 6, and here it is 2 4 the 8. Here it is 8 volts, 2 4 the 8. Here it is 6 volts, and here it is 4 volts, and here we have 2 volts, right? If I combine all these, 8 plus 4, I mean 8 plus 6, 14 plus 4, 18 plus 2, 20 volts, which would be equal to the total potential difference that we have applied in the circuit. So this is the first example. Let's move on to the second example. Okay, let's look at this diagram. We have three resistors which are connected in parallel, and here we are given with one more resistor, which I am showing it here, 3 ohm resistor, 3 ohm resistors. Now these 3 resistors connected in series. Now I am taking it as R1, So okay, one moment. R1. So this will be the equivalent resistance of all these 3 resistors. So in case of parallel combination, the equivalent resistance will be 1 by R1 plus 1 by R2, so on, whole inverse, right? As we have 3 resistors here, I am going to write the equation something like this. Okay, R1, I've considered the equivalent resistance of all the 3 resistors as R1. R1 is equal to 1 by, what is it, 12 plus 1 by 6 plus 1 by 4 whole inverse, right? So this will be equal to 12, 6 and 4. LCM, here we have 12, 6 4s are 24, here we have 6, 12 4s are 48, 12, okay, now 4, 72, whole inverse, right? Okay, now what am I getting here? So 24, 40, 70, 110, 110 plus 8 plus 2, 120, 120, 144, 144 divided by 12 into 24. So this is 12 12s are 144, 1 by 2. As it has whole inverse, it has also whole inverse. This R1 will be 2 ohms, as we have inverse here. Okay, R1 will be 2 ohms. Now this circuit will be something like this. This is 2 ohms and this one is 3 ohms, and here we have 60 volts power supply. This entire group of three resistors has simplified into one resistor. Now these 2 ohms and 3 ohms are connected in series. So combination of these two will be series. In case of series combination, the equivalent resistance is R1 plus R2 plus R3 and so on. As we have only 2 resistors, this R equivalent of the given circuit is, what is it? 2 plus 3 is equal to 5 ohms. 2 plus 3 is equal to 5 ohms. I hope the solution is clear to you, right? R equivalent is equal to 5 ohms. Now, let's look at one more. You can even find the currents and potential differences across each and every resistors, as we have already discussed in the earlier example. Okay, look at the next example, right? In this example, we have these 2 resistors which are connected in series. Okay, I'm going to identify the resistors which are connected in series and parallel in the small branches. I'm going to simplify them into single resistors, and finally I have to come to a conclusion where I'll have only one resistor connected in the circuit. Okay, that resistance of that resistor is called equivalent resistance. Now these two are connected in series, so I'm taking it as R1. So if I find this resistance R1, as these two are in series, the equivalent resistance of the resistors which are connected in series is the sum of individual resistances, which is 2 plus 1 equal to 3 ohms, equal to 3 ohms. Now the circuit will be something like this: 4 ohms, 4 ohms, 3 ohms, sorry, and here we have 3 ohms, and here we have 6 ohms, and here also we have one more resistor, 4 ohms. This is 4 ohms, this is also 4 ohms. As you can see, now these two resistors are in parallel, I'm taking it as R2. As we have already know how to find the equivalent resistance when the resistors connected in parallel. The formula is simply R equivalent is equal to 1 by R1 plus 1 by R2 plus 1 by R3 whole inverse, right? So I am going to directly write the numbers. I'm not writing the formula here. R2, what is it? R2 is equal to 1 by R1, which is 1 by 3, 1 by R2, which is 1 by 6 whole inverse. Or else I can directly write the formula R1 R2 by R1 plus R2. In both the cases you will get the same result. LCM is how much? 18, 366, 6 3 is 3 whole inverse. How much is it? 2 ohms. R2, sorry, R2 is equal to 2 ohms. R2 is equal to 2 ohms. Now the circuit has further simplified, something like this: 4 ohms, again 4 ohms, and here it is 3 ohms. Here it is 3 ohms, and we have 4 ohms here, 4 ohms here, 4 ohms, and we have one more resistance which is 2 ohms. We have already obtained over here. Now these 2 ohms and 4 ohms are in series. I'm writing it as R3. This R3 is nothing but sum of individual voltages, 2 plus 4, which is 6 ohms, which is 6 ohms. Again this circuit is further simplified. Battery 4 4 3, and here it is 6 ohms. Now, as you can see, these these two resistors are connected in parallel. As we already know, when 3 and 6 are connected in parallel, the result will be 2 ohms, 2 ohms, right? I'm taking it as R4. Again, R4 is also 2 ohms. 6 into 3 by 6 plus 3. R1 R2 by R1 plus R2, which is equal to 2 ohms. Now the circuit will be something like this: 4 ohms, 2 ohms, 4 ohms again connected here, 120 volts. Okay, 4 ohms, 2 ohms, 4 ohms, right? Now all the three resistors are connected in series, end-to-end connection. As these three resistors are connected in series, the equivalent resistance in series is R1 plus R2 plus R3 plus R4 R5. How many? 4 plus 2 plus 4, which is equal to 10 ohms. So 10 ohms is the equivalent resistance of the given circuit of resistors. Hope I made the point clear to you. Hope the solution is understandable. Okay, let's have a look at another example here. Yes, this one. Okay, I need the equivalent resistance between A and B. Between A and B. Okay, I am going to simplify the entire circuit into one single resistor. Now, let us identify which resistors are connected in series and which resistors are connected in parallel in small branches, and simplify them till you get one single resistor. As I can see, these two resistors are connected in series. Okay, now as 3 and 3 are connected in series. Now this I am taking it as R1. R1 is equal to 3 plus 3, as they are connected in series, which is 6 ohms. Okay, now this is 6 ohms, this 6 ohms and 6 ohms, these two are connected in parallel, are connected in parallel. are connected in parallel. 6 and 6 connected in parallel. So R2 is equal to 1 by 6 plus 1 by 6 whole inverse, or else you can even take R1 R2 by R1 plus R2. R1 R2 by R1 plus R2. 6 into 6 by 6 plus 6. You can skip this one. 6 into 6 by 6 plus 6. 36 by 12, which is 3 ohms. Which is 3 ohms. Now, 3 ohms, sorry. Okay. Which is 3 ohms. Okay, 3 ohms. Now, this group of resistors connected in series with 3 ohms, right? Series with this will be one single resistor. I'm going to draw this again. These 3 resistors, I'm taking it as one single resistance of 3 ohms, as you can see. Okay, one resistance, 3 resistor, and here we have 3 ohms, something like this. Okay, and here we have one more resistance, which is this one. This is 3 ohms, and here R2 is 3 ohms again, and here we have 6 ohms, and again 3 ohms, again it is 6 ohms, and again 3 ohms, and here we have 3 ohms. This is the circuit A and B. Okay, now this 3 and 3 are in series again. Okay, right? R3, I'm taking it as R3. Now find R3. R3 is nothing but 3 plus 3, as they are in series, 6 ohms again. Right? Now coming to this 6 ohms, this combination, and this 6 ohms are connected in parallel. This I am taking it as R4. This I am taking it as R4. What is R4? R4 is equal to R1 R2 by R1 plus R2, as these two resistances, resistances of the resistors are same, 6 and 6. So 6 into 6 by 6 plus 6. Again 3 ohms. Again 3 ohms. Or else you can directly use the formula R by N, which is 6 by 2, which is 3 ohms. So this R4 is equal to, R4 is equal to 3 ohms. 3 ohms. Okay. Now here we have 3 ohms, right? Okay. Now this 3 ohms and 3 ohms are in series. I'm redrawing this diagram. 3 ohms and 3 ohms. Okay. Now here we have another 3 ohms, right? And here we have another 6 ohms. We have 3 ohms here. Across these two terminals only, we need to find the equivalent resistance. Okay. Now we are left with only 1, 2, 3, 4, 5 resistors. Now, as I know, these 3 ohms and 3 ohms are connected in series. Now this will be 6 ohms. This will be 6 ohms. And these 6 ohms and 6 ohms are connected in parallel, as you can see. Now 6 and 6 will give us 3 ohm resistance. How much is it? 3 ohm resistance, right? Now again, I'm redrawing the circuit. 3 ohms, 3 ohms, 3 ohms. This is 3 ohms. This is 3 ohms. Sorry, 3 ohms. And here it is also 3 ohms. Terminals A and B. Now 5 resistors have become 3 resistors. Now as you can see, 3 ohms and 3 ohms are connected in series. So the result will be 6 ohms. Right? Now these 3 resistors have become 2 resistors. This is A, this is B, 6 ohms, 3 ohms, 6 ohms, 3 ohms. So as these two are connected in parallel, the equivalent resistance between A and B is equal to R1 R2 by R1 plus R2, as these two are connected in parallel. 1 by 3 plus 1 by 6 whole inverse, if you simplify it, you will get 6 into 3 by 6 plus 3, which is equal to 2 ohms. 18 by 9. 18 by 9, which is equal to 2 ohms. So finally I have got the equivalent resistance. R equivalent is equal to, how much is it? 2 ohms. R equivalent is equal to 2 ohms. Okay, now let's look at one more example. Here we have many number of resistors. We will simplify one after the other. As you can see, I'm going to write the steps directly. I'm going to take the equivalent resistances of small branches directly. I'm not going to use step by step solution here because we have already gone through few examples. Okay, now 6 and 3 are connected in parallel, so the equivalent will be 2 ohms, as we already know, right? 2 ohms. 6 into 3 by 6 plus 3, 2 ohms. Now this 2 ohms and 10 ohms are in series. So this will be 12 ohms. 12 ohms. Okay, leave it like this. Finally, sorry, this is a 12 ohm resistor which is here, because it is 2 ohms and this is 10 ohms, which is 12 ohms. Now here 9, 9, 9. All the three 9 ohm resistors are in parallel. As we already know, when resistors connected in parallel with equal resistances, then R equivalent is equal to R by N. Here R is 9 ohms, N is number of resistors 3. Okay, so this will be how much? 9 upon 3, which is equal to 3 ohms, and this 3 ohms and 1 ohm are connected in, this 3 ohms and 1 ohm are connected in series. 3 and 1 ohm are 4 ohms, right? Now here we have 4 ohms and 2 ohms. These two are connected in series, 4 and 2 together, which is 6 ohms. 6 ohms, right? Now we have our simplified circuit, and this is connected to another resistance, something like this, 32 volts. 32 volts. And this resistance is 7 ohms. 7 ohms. Hope the direct step that I followed is clear, right? Okay, now let us simplify this one into a single resistor. So as these three resistors are connected in parallel, R, let us suppose this entire resistance is R1. R1 is equal to 1 by 12 plus 1 by 4 plus 1 by 6 whole inverse, as they are connected in parallel. I am going to take 1 by 2 as common. Here it is 1 by 6, 1 by 2 and 1 by 3 whole inverse. What am I getting here? If I find the LCM, 1 by 2, 12 3s are 36, 36, 6, 18 plus 12 whole inverse, right? Whole inverse. How much am I getting? 18 plus 12, 30, 36. 18 plus 12 is 30, 30 plus 6 is 36, 36 by 36 is 1. 1 means we have inverse here, so I am getting 2 ohms resistor. 2 ohms. How much is it? 2 ohms. R1 is equal to 2 ohms. This entire thing is 2 ohms. Now the circuit is further even simplified into two resistors, one, and is connected to another resistor. This is 2, this is 7 ohms, and these two are connected in series, as you can see, end-to-end connection. So these two are connected in series, so the equivalent resistance will be R equivalent is equal to 2 plus 7, which is equal to 9 ohms. So the circuit is further simplified as like this: 32 volts, 9 ohms. So this is how we need to find the equivalent resistance by using successive reducing method. Okay, so hope the examples that we have gone through are clearly understandable. Right, hope the lecture is helpful to you. If you find the lecture is helpful, please do like, share, subscribe, and don't forget to hit the bell icon in order to get the notifications as soon as I upload the videos. So that's it in this video. Thanks for watching. See you in the next video.